So our next speaker is Monty Barlow from Cambridge Consultants, who heads up the artificial intelligence practice and is our gold sponsor. So thank you.
Okay, so yeah, I lead artificial intelligence at Cambridge Consultants, including running a research lab, which gives us some kind of visibility in our own way about what's coming in artificial intelligence. There's a simplistic accepted wisdom that AI and big data are symbiotic, and this is true. Yeah, AI is needed to make sense of big data, and we've been hearing about a lot of applications of that today, and that conversely, big data is needed to build AI, and that has particularly been true over the last 10 years, where it has helped deep learning push AI forwards at a rate we've not seen before. But I think there's questions about whether this part of it really is true. The problem with AI, or the opportunity, is that the goalposts are moving the whole time. What we call AI changes. So today's pattern matching, image classification, and so on that has seemed so smart may well not be. And big data may actually hold us up in moving forwards. I'm going to try and argue this in 7 minutes flat. So bear with me. So if you think about how you use big data for an application AI, suppose you wanted to read bumper stickers with a smartphone camera. Your data set for training that AI would include all possible bumper sticker designs at some level you might want to detect. But you have to multiply that up by all the other variables you have to deal with in practice. So camera angles, weather, deterioration, anything that makes it just a bit more tricky in practice. So you end up with a big data silo. That one silo helps you address one very narrow problem. If you then want to turn your attention to something actually quite similar technically, perhaps you want to detect skin tumors with exactly the same imaging system, and you've still got camera angles and weather and time of day and other problems to deal with, that first silo does you no good whatsoever. The sheer fact that you went so niche and narrow on one AI prevents you doing something a bit broader and more flexible. And when I talk about the goalposts of AI moving, it's quite obvious, I think, that we need to move to broader applications. The only people who really see this picture as good are those who have silos who are hoping to sell them. So just briefly, before we go into a fun demo, just think about how you learn to drive. So human being is the best example of intelligence we still have today, and the best example of driving a car we have. You don't need more than about 50 hours of practice in a vehicle, of tuition and reading the highway code to learn to drive. The reason you can do that is that 17 years plus of broad experience practicing, experimenting with the world, working out how physical objects move and the weather works and what people culturally are likely to do. So it's a tiny big data silo, if you like, on the left, and this broad experience that you can use for any application you wish to turn your hand to. And this is really what we want AI to be able to do. It's quite obvious if we're going to tackle big problems, that's what we need to be able to do, get closer to the human model. So I'm arguing that we don't need more data silos, we don't need bigger silos to push forward state-of-the-art in AI. We need new algorithmic approaches that can learn from practice and experience with the world. I'm going to show now an example of a technology we've only publicized this week called DeepRay, that is all about algorithms, a new approach to handling much less data. How good it's working. So I hope you can perceive some fish that look pretty distorted swimming around. You know, you're using all of your visual training to work out that they're probably behind distorting glass and that they're not fish that are changing shape as they swim around. This, on the right now, the split screen, is frame-at-a-time processing by DeepRay automatically of that distorted image into what I think you agree look like pretty whole, healthy fish. You could, on the right, now run a fish detection algorithm, a fish counter, health, whatever you wanted to do. It's almost like a mind's eye where the AI is seeing through the distortion and the problems to what is really there. And this has been very difficult to do in the past. If you look at that final split screen, you can see the weed even looks better on the right than on the left. That play out. The way this learns is quite interesting in that it has very little data into it in the conventional sense. A few hundred images is all it plays with, a few pictures of objects in the real world, but it practices sliding them around behind bits of glass and other distortion we give it, much as a toddler might, peering through a window, moving their head and seeing what happens. And it builds up a whole load of experience data. It's still more photos, but it's not big data in the classic sense. It is generated out of experiments. It sits and chews on that for about 3 days in a neural network, which is the distant descendant of those early image classifiers. It is still deep learning. It's still AI as we know it today. But the result is it gets this ability to imagine what is behind degradation, dirt, and so on. I think it's always interesting just to see these systems in progress. So if we stop the training early on, after 1,000 iterations, you can see it's struggling to reconstruct whole fish. It doesn't know if there's 2 silver ones at the right edge of the frame or not. The eyes all look a bit wrong. But left to play with its own experience for 3 days on heavy compute, what you eventually get is a system that's able to reconstruct real fish. I need to hurry up. So this is a low data approach, but more importantly, this sort of system forms a broad base for AI. It removes all of those problematic variables we needed deep learning to deal with, and instead enables AI to get on with the job of whatever it is, bumper stickers, fish, or whatever, with a broad capability to see the real world as it is. Thank you.
Thank you very much, Monty. Okay, our next speaker is Neil Lawrence, who's with the University of Sheffield and also has a role here in Cambridge with Amazon. So over to you, Neil.
Thank you, Peter. So I thought I'd also talk without slides and try and be influenced from some of the earlier speakers in the day. So this dichotomy that Peter asked us to talk about of data and algorithm, I think is a very interesting one, and I started mapping it into the sort of landscape of people who were trying to deploy innovation based on this technology, AI, today. But to do that, I always think it's useful to sort of go back and think about innovation in general. So to me, if you're going to successfully deploy innovation, and I think it's remarkable the amount of undeployed innovation we have in AI in terms of stuff that isn't doing anyone for anything, but is publicized quite widely. The first thing you need is to have innovation, but let's just take that for granted. If we're going to have innovation and we want it to deploy it, the first thing we need is a business problem that needs to be solved. Now, I thought what was interesting from different sessions we've had today, some of those different problems, and I particularly enjoyed Rosalind's talk in the morning where she was talking about her father working out that trains needed water removal in order to stop their brakes freezing. So that's a business problem. It's a clear business problem, and her father moved to deal with it, and a successful product. Driverless cars. Another business problem, but of a very different type, a little bit more diffuse. This idea that people will want to get around without driving their own vehicles, but less well-defined. I think that the interesting thing when we're looking at business problems is the extent to, when we look at those two, for example, we're looking at the case where we've got an existing space where we're solving an existing problem, or a new space. And the driverless cars sort of somehow falls in between, but other examples that were mentioned were things like SMS, and the surprise of SMS in being a major area of revenue income for mobile phones. I remember a period when everyone was telling me that 3G was going to be all about spending £1 to watch football goals. That was the main motivation why we wanted video on our phones. At the time, I remember myself not really knowing why I wanted video on my phone. But it wasn't to spend £1 on watching football goals. Because when new technology comes along, it's extremely difficult to forecast how it's being used. And we're seeing that with a number of the different technologies you've spoken about today. And I think AI definitely fits in that class. Often the sort of technologies, the applications come out of the left field. So the business problems that I can envisage for AI may be very manifold, but I think that what's exciting is that the overall ecosystem of startups will produce the things that I won't have thought of, that will make the things that make a real difference. And examples I'm thinking of coming out of the internet, we all may remember Friends Reunited, which we all joined very, very quickly, and then after they started trying to charge us to be members, we stopped using. Personally, I don't think Facebook was that different, only they had a different business model. And it's interesting how long it took to get to social media as such a dominant business model. I mean, about 10 years since the invention of the internet. I mean, it's not that none of the technology was there. All that was envisageable. It's just connecting people. A lot of it's about platforms and understanding how to use the technology. So that brings me to the second, well, the three. If you've got innovations the first, business problems the second. I think perhaps the thing that is then conflated with business problem, but I view as separate, is the deployability of what you're doing. So the deployability of what you're doing, I broadly categorize into two sets. First of all, brownfield deployability. That's the case with driverless cars. It's not the case that people can't get around at the moment. There are many ways of getting around. You can take trains, you can take bicycles, there's an existing ecosystem of transport. Trying to innovate in that space, as our speakers in the last session were trying to do, is trying to take an existing ecosystem and modify it technologically using new ideas, but you're having to do it on top of an existing ecosystem. That makes it very, very hard. Greenfield innovation is the case where you're just coming fresh to the problem. No one's ever done anything like this before. You invent something that everyone wants. I would say sort of social networking is a little bit more like that, perhaps, or was a little bit more like that. If we think of Rosalind's dehumidifier, it's a lovely story, but of course she hinted at this in the story, the years it took her father to go from the idea to the realization. And that's all about the deployability, because her father's initial dehumidifier was, as she said, taller than herself, and the final thing that's fitted on a train is this size. We're very much in that situation with artificial intelligence. There's nice examples of the sort of scale, as we were just hearing from the previous speaker, of how much data it takes to do AI at the moment. But technology is changing. People are developing chips to allow it to deploy on mobile phones. And that sort of technological change will very much change the way in which we can deploy. I thought, listening to the Iridium speaker in the satellite session, I think I heard correctly that you needed a bankruptcy to get to your deployable stage. The business problem is clear. Everyone wants to be able to speak from anywhere in the world. That's obvious. But the deployability of the system is extremely difficult. And that's why it takes such a large investment and a very different nature to where we are with artificial intelligence. Very fortunately, with artificial intelligence, in some sense, anyone can go and write an app. You can be a successful AI innovator making a cool app that does something with AI on a phone, and you can make yourself multiple $1 million very, very quickly. You don't even need a large startup or very much funding. That is not the situation if you're trying to deploy satellite phones. Another example that I was traveling across last night was the Channel Tunnel. Excellent idea that you can just get a train to Europe. Of course, that's gone bankrupt once, and getting money out of that. The deployability of the idea is a different scale. But that's the beauty of artificial intelligence and AI, because in some sense, you can do it in your shed. But is that fully true? So the next thing I just wanted to do is make a distinction between data science and AI, which I think is very important. To me, actually, data science is that problem of dealing with big data. So data science is the challenge of we're laying down an enormous amount of data by happenstance, right? So there's a load of data just appearing, not because anyone's thinking about it. I call it hearsay data. People have heard they've got the data, so they say they've got the data. But when you go and look at the data, it's often rubbish and can't do anything that you believe it wants to do. Whereas AI, traditionally, I'm a machine learning researcher myself, but AI traditionally was, let's just emulate what humans can do. Let's emulate intelligence. It just happens that at the moment, the best route we have to that is through data. But not through necessarily picking up data that's laid down by happenstance, by actually thinking about a data set, creating a data set. The big breakthroughs in vision were 14 million images labeled on Mechanical Turk that enabled neural networks to compete with humans. People thought very carefully about how to collect that data. It wasn't laid down by happenstance. It's true that they could get the images off the internet, but then the data set and the labeling of the data set needed to be thought about a lot. And this is a critical thing if you are looking to innovate in this space. You need the data of some form in order to answer the question. It may be that you own the data because you may own an ecosystem, but then you need then you need to deal with the challenges of processing that data. Because as a result of all this, most of it at the moment seems to come down to data ecosystems. So one of the things I've noticed is there's an enormous amount of talk about the shortage of people who can do machine learning. I don't think that that's what's going to constrain us from an innovation perspective at all. I think that the shortage of people who understand data, how to process data, how to distribute data, and how to build data ecosystems, we don't even have courses in how to do that today. And we have a few courses in terms of little bits around it, small amounts of data cleanup. But the actual challenge of bringing data from the silos that it's in and making the judgment calls about how the data should be brought together, what data is valid, what data needs to be recollected, those are the real challenges of deploying AI in the real world. Most of the algorithms are there on open source software. Knowing which algorithm to deploy in which circumstance is the key. Sometimes I think of it a little bit like the flush toilet. The flush toilet's a wonderful invention, but it actually requires plumbing before you get one. Otherwise, you end up with a cesspit in your garden. If you don't have that sort of planning, you're not going to be able to deploy machine learning. Another analogy, I think, is the amount of time it took electricity to go from existing to driving industry. Tim for Harford, who writes for the Financial Times, wrote an article for the BBC on how long it took to go from factories that were driven by steam, which is clearly less portable and deployable, to those that were driven by electric machines. And a lot of it was about building small electric motors, such that your machine, which was being driven by a band from a large steam engine, just replacing that with an electric motor didn't give you a significant advantage. It gave you an advantage when you could bring the motor inside your machine and you could reconfigure and redeploy your factory. It's the infrastructure that brings the sort of big wins, certainly in the brownfield areas. That's also known as the Solow paradox in economics, where computers were everywhere but weren't in the productivity statistics. The real challenge at the moment is we don't even know what the plumbing is. We've heard various visions from different companies about what they think the plumbing is. But to be frank, until we all agree on what the plumbing is going to look like and start interacting together, brownfield innovation is going to be really, really difficult and much slower than we expect. And that's why we had a wonderful talk from Gartner. On the Gartner hype cycle, we will go through a trough of disillusionment. However, I think that's when we're thinking of the large-scale brownfield innovation and large data infrastructures where we're looking to bring artificial intelligence in. There is that other area, which is a beautiful area of the left field innovation. And in that space, we can move extremely quickly. If people come up with an idea of an AI system that requires a small amount of data, that requires existing algorithms, and they can deploy it very rapidly via the mobile phone, there are enormous opportunities there. Of course, you know, when companies like Magma are not worried necessarily about those opportunities, they're worried about the disruptive things to their own business. So that's why you hear so much talk about the brownfield innovation. But the most exciting stuff, I believe, will happen in the greenfield innovation. With that in mind, one of the things I do regularly, and we're just in our 5th year, is sort of Data Science Africa, which is for me, it's definitely not a charitable thing. It's just you go into the African environment where they have large-scale 4G networks. They have very good bandwidth. They have very poor existing infrastructure. Transport is hard there. In that space, most innovation is greenfield innovation. If you want to introduce a health system on the mobile phone using machine learning algorithms based on local data, you are not replacing an existing health system which already has an enormous number of benefits. And that allows innovation to move much, much faster. So one of my hopes, beliefs, is that we will also gain some form of inequality because, or more equality within developing countries, because the beauty of these systems is once you've got the information infrastructure, the additional investment is just that of people who are interested and innovative and trying to deploy, if you're in the greenfield zone. So I kind of think it is about a number of things. It's about having the data, but more importantly, it's about data ecosystems, particularly if you're trying to innovate in an existing space. But the beautiful thing is, if you are a young entrepreneur who is interested in these areas, there are many, many opportunities to build something at this moment, which other people haven't thought of, which will change the way we all live in ways that none of us have thought about. And that's it.
Brilliant, thank you, Neil. Okay, so when the next bunch of bright PhDs knock at your door to sell you an AI solution, or perhaps knock at your door looking for investment from Mrs. G-Wiz AI and Co., how do you decide whether you know they've got some clever algorithms and it's going to change the world, or something else? So I'm very pleased to invite Amelia up from Amadeus Capital Partners to give us a different perspective, to give us an investor's view on AI. So Amelia, over to you. Thank you.
Thank you. I do apologise, I have a slightly croaky voice, and it's not because I spent a week in Russia. So, how does a 3-person machine learning startup think that they can compete with the tech giants who've collected vast amounts of data over many years? Is it possible for these machine learning startups to generate a product that can be taken to a global scale? And all of the CEOs of the companies that we've invested in will definitely say, yep, it's not a problem. And so I want to discuss today why that is and give you some examples of 3 companies that we've invested in. Now, one of the main reasons why they can compete is that they all have very cutting-edge algorithms. So a lot of them will have come from the research that they've done in their PhD or master's courses. But the second reason is that they really understand those algorithms. And as Neil was talking about, they really understand the data that is required to train those algorithms. So they don't require vast amounts of data. They just require very specific bits of data. Now, as I'm sure you know, an algorithm is trained on data where you know the input and the output results. And a very simple example is if you wanted to generate an algorithm to predict house prices, you would train that on sold house price data versus the square footage of those houses. And then if you wanted to then, once you've trained it, predict what the selling price for a house price might be, you would use the algorithm and input the square footage, and it would give you a potential value. Now, it's important in that example that if you're interested in retail houses, that you don't train on with commercial property data, because you'll then create a very different prediction model. And so what I'd like to now go through is 3 companies, the first of which is Speechmatics. So Speechmatics is a Cambridge company which does automatic speech recognition. So they convert speech to text in real time, and they can do that in over 70 different languages. And where they're used, and so a couple of the use cases are to add subtitles to TV programs, or for automatic transcription in call centres, which might be to assess the call centre workers or as part of an automatic response. And what's interesting is that they've grown the number of languages that they can transcript from 30 in 2016 to the 70 today. And they can train very quickly into new languages. Now, their competitors, when they're looking at training in a new language, will start from scratch and start with new data. But what Speechmatics do differently is that they look at the common themes between languages. Now, you might be interested to know that the human voice can make 150 different sounds. Now, I'm afraid that excludes African tribes with clicking, but the main languages, there's 150 different sounds which are called phonemes, and each of our languages is made up of 40 to 60 of those phonemes. Now, if like me, you have school-age children, you'll know that they're taught to read phonetically, so they break down words into the different sounds and then sandwich them back together again. And there's a rule of how you sandwich them back together again. And that's how the languages are made up, so 40 to 60 different phonemes, and then with rules about how you put those phonemes together. And so once you know these rules and the phonemes, you've then created quite a simple machine learning problem of how to do the transcription. And so Speechmatics have built their model once based on these phonemes, so they don't need to restart each time they move into a new language. A language which they've just done is Malay, and what they've done is used open source data which is available to anyone to build the initial model. And then when the customer is happy with what they've seen, they've then been provided with private data which is in the specific domain that the customer wants to use the transcription. And once they have that specific data, they can then train the algorithm so that it really gets the word error rate down. But for making that first proof of concept, the data that they have available to them is the same as any of their competitors. So they're a good example of a company which has a very smart algorithm, but is using data which is not necessarily unique to them. The next company is Helix. So they're working on repositioning existing drugs to treat rare diseases. So there are about 7,000 different rare diseases, of which only about 5% have a treatment for them. And this number of 7,000 is steadily increasing as more genetic research is being done. And if you can use an existing drug to treat a rare disease, it's much quicker to market and it's much more cost efficient. Now, drug repositioning is not new. You will all know about aspirin and Viagra, which are used for very different purposes than they were initially developed. But what Helix are doing is converting what was more of a dark art into a scalable business model by using machine learning. And the first part of what they needed to do is to build up a database. And so their aim over the next couple of years is to build a database of 1,000 rare diseases and have within that 100 million relationships. And a relationship might be the connection of a gene to a particular disease or a drug to a particular side effect. And once they know these known relationships, their algorithm can then go on to predict new relationships. But the building of the database is hard, and that's one of the unique selling points of Helix. So they use public data which is available to anyone, so such as scientific papers and patent applications. But what they're also able to get is private data, and they get this from patient charitable groups who support a number of the rare diseases. And the patient groups will provide them with this non-public data. So that might be results of treatments or observational outcomes or particular therapies that have been tried. And so once they've built this database, they then need to go through the database with very experienced people to annotate the database so that it can be used by the algorithm. And so at the end of this process, they will have a very unique data source with tags which can be used by their algorithm. One of the examples where they've had some success is with Fragile X syndrome, which is an inherited disorder, which is a one gene defect, which leads to intellectual impairment. It's a very common problem which currently has no treatment. And they've been able to identify 8 potential molecules, of which 3 have been taken to further testing. So they're a good example of, again, a great algorithm, but here they have a very specific data source which will underpin their value. And the last company is PolyAI. So PolyAI are building a platform for conversational apps, which will be used on Amazon Alexa or Google Home or Facebook Messenger. And they are designing these conversational apps so that they will be much more intuitive. So you will have a better conversation with the technology. An example might be that they would get used for booking flights or booking restaurants. And they want the experience to be much more intuitive. So if you go to book a restaurant, such as you speak to your Alexa and say, hey, can you book me a restaurant or book me a table tonight for 2 at the Ivy in Cambridge? Then they want the response to be more like, oh, I'm sorry, it's booked, but why don't you go to Midsummer House because the ratings there are very good and we can get you a table there tonight. So they're working to develop these sites using Amazon Mechanical Turkers. So what they do is when they want to train in a new domain, such as booking for restaurants or flights, they use the real conversations that they've set up on the Amazon Mechanical Turker system to train their data. And they can get about 500 conversations between real people about what words they use to make a particular booking. So they go out and get the data as they need it to train in each new situation. So they are not restricted by any data that is currently in existence or needing to get access to other people's data. They can just go and get their own as needed. Now, hopefully, I've shown you that it's the algorithms combined with these unique data sets which leads to the startup companies able to have that competitive advantage over the large software companies. You know, there is hope for these Davids against the Goliaths, and we see a number of great companies like this that are using the algorithms and the data in specific ways. Thank you.